All right, in class problem number 11 is the only problem we're going to do together today. And then I'm going to give you some chances to work on this. So we've kind of introduced the idea of max height problems, and sometimes it's beneficial to set this up as a max height problem. Sometimes it's beneficial to set it up as a delta y is equal to 0 problem. It kind of depends upon what you want to do along the way. So a super ball is bounced on the ground and it leaves the ground with a velocity of 19 meters per second. So the idea is if I take this ball, now it bounces up and it comes back down. So once it leaves the ground, it's going up at 19 meters per second. What is the maximum height? How long is it in the air? And with what velocity does it hit the ground again? So pretend like it doesn't hit, oops, that's loud, negative 19. Okay? This ball leaves the ground at 19 and it lands back on the ground again at 0. Or I'm sorry, it lands back on the ground. Is it a 1D motion problem? Is it a free fall problem? Is it a max height problem? Is it a delta y is equal to 0 problem? Okay, so we kind of go through that whole long list. But if the ball leaves the ground and it hits the ground, we could consider it to be a delta y is equal to 0 problem. Correct? You agree with that? So what the original intent of doing that last problem is to say what is the velocity at which it hits the ground, is to kind of like prove that, hey, if we were to go from max height back down, that it would be negative 19.8. I'm sorry, negative 19. But if it's a delta y is equal to 0 problem, and my VI is equal to 19, according to our problem type, if it's a delta y is equal to 0, what's true about your VF? VF is equal to... Sure. No, I don't remember exactly what I said. But if it's a delta y is equal to 0 problem, the ball leaves the ground at 19 meters per second, and it lands back on the ground, it's a delta y is equal to 0 problem, right? So if this is my initial velocity at 19, according to our problem type, what's our final velocity? Right, my sheet says VF is equal to the opposite of VI. And if my VI is 19, then the opposite would be negative 19. Okay, so I'm not going to do that last calculation. Originally, like I said, I had put that on there as a way to say, like, well, if we went from ground to max height, and then we went from max height back down, it's a way to kind of prove that it is, but I'm not going to do that last part with you. So let's kind of break it into two parts. What is the max height of the ball? Okay, so is this a 1D motion problem? Yeah, it's a 1D motion. X or Y? Y. Y. Is it a constant velocity problem? No. Is it a free fall problem? Is the only force acting on the ball, once it leaves the ground and until it hits the ground, gravity?
Yeah.
Yes. So therefore, acceleration, negative g, negative 9.8. Is the object dropped or does it just fall off of something? Nope. So don't say that one. Is it a max height problem? Well, if we're going to say what is the maximum height, yeah. Okay, so that means it can't be both. It can't be a max height and a delta y is equal to 0 because that's the maximum height. That's right. That's the maximum height, and then this is when it hits again. So they can't be both of those. So if we go through and say, well, this is a delta y, VI, VF, A, and T. We said it was a free fall problem. And we said it was a max height problem. So again, pictures are going to be kind of nice. Pictures are going to be somewhat helpful, I think, just to kind of help set these up and figure what you got. So we could go from here to here, and at max height, our velocity is 0. Now, if it is moving upwards at 19 meters per second when it leaves that ground, that's also going to be some type of velocity. So we're trying to figure out how high did that thing go, that's our delta y. Is 19 my VI or is 0 my VI? 19, right? And it's just to emphasize, it's a positive 19. It's going up. It doesn't affect your calculations, but I'll just put it there just for today, just to kind of show you. And because it's a max height problem, we can say at maximum height, which in this case we're comparing the ground to maximum height, we can say my final velocity is 0. So how high did my object go? Don't know time, don't really care about the time. Equation. Right, we're looking for the equation that doesn't have time in it, and that would be 4. So VF squared is equal to VI squared plus 2A times delta Y. Final velocity was 0. 0 squared is 0. So 0 is equal to 19 squared plus 2 times negative 9.8 times. Then we go through and we solve this thing. We get 0 is equal to 19 squared, which is 361. Then 2 times negative 9.8 is negative 19.6 times y. So negative 19.6 times 1. Now you have some options on how to isolate y. You could add 19.6y to this side. You could subtract 361. Doesn't really matter. I'm going to subtract 361. Can we see this red, or is it too? Not really. People in the back? Not really. Not really. Okay. So I'm going to subtract 361 to the other side. And then the last algebraic step is we divide by 19.6. Negative 19.6. And we should get 18.42 in our units of meters. The most important thing on all these problems is identifying what the numbers given in the problem represent, identifying the problem types, because the problem types help us fill this in, and then based upon what variables we have, picking the right equation. From there it's algebra. And I'm not going to say this is the easiest algebra, but it's not like, it's generally single algebra, variable algebra. Okay, so it shouldn't be too hard. It should be stuff that we should be able to do. But if you get stuck on something, it's like, how do I do this? Like, what's the next step? Just ask, and I'll help you kind of get that figured out, because this is going to be stuff like algebra we're going to be doing all year. So we just want to make sure we get that taken care of. Okay, so that's how high it went. Now, the follow-up question is, how long is it in the air? Now, if I were to go through and solve for t right here, what is this going to give me the t of? How long it took the ball to go from where to where? From the ground to max height. Now, is that what this question is asking? No. Okay, it's not. So, but this is a delta. If it lands back on the ground at the same height, is this a delta y is equal to 0 problem? It could be then, right? So if we say from here up and down, because that's what this is asking, total time in the air, we could say this is a delta y is equal to 0 problem. And if that's true, what's true about the time to max height compared to the total time in the air? We multiply by 2. Okay? So the way this problem is set up right now, we could simply go through and solve for t, but keep in mind that's only going to get us 2 max height. Bless you. But then, because it's a delta y is equal to 0 problem, because it's going to come back down, we got to realize that it's coming back down, that we could simply double this. The other option is a kind of a different approach to it, and I'll show you that. Is what if we would treat this problem as a delta y is equal to 0 problem and only a delta y is equal to 0 problem. So if we said this is a delta y is equal to 0 problem, which means that the ball leaves the ground and then it lands back on the ground, so my delta y is equal to 0. Because my initial velocity was 19 meters per second, sorry, I forgot the per second, 19 meters per second positive, what's my final velocity then? So we're starting here on the ground, is going up at 19, it reaches max height, but then it's coming back down. What's the velocity when it comes back down? It's going to be negative 19 meters per second. It's still a free fall problem, so this is going to be negative 9.8 meters per second squared, and we could solve for t that way. Now, the reason I'm showing you this, I would agree, this makes, if we had already done this step, I would probably solve for time and simply double it. But sometimes it might be, like, we didn't ask, like, how high did the ball go? If it simply was how long was in the air, then this would be an approach we could take. So I just want to show you that. Now, in any given problem or any given equation, there's 4 variables. And of those 4 variables, we need to know 3 out of the 4. Well, in this particular case, we have 4 out of our 5 variables in our list. So we have some choices, we have some options as to which equation we could use. We just got to make sure there's a timing. Okay? We could do equation, we could, and I'll erase, we'll pick one and then we'll choose it. We could do equation number 2 because we have VF is equal to VI plus A times T. We could solve for T. We could do equation number 3 because that says delta y is equal to VI times T plus 1/2 AT squared. We could solve for T. Now some of you might be like, T and the T squared. The nice thing is we got a 0 in there. So with this being equal to 0, we get 2 solutions, one of which is 0. And the other one we can factor out a t, and then t is equal to 0, and so it's not as bad as it looks. So we could. We don't. I'll write number 4. We don't want to do equation number 4. We don't want to do this one because there isn't a t in it. Or we could choose equation number 5. And we could solve for t. Now, be careful with equation number 5 because if this is negative 19 and this is positive 19, yeah, it's gonna give you some issues. Okay, so we do have some choices. I think equation number 2 is probably one of the simpler equations. So that's the one I often go to because it does have a t in there. So that's what I'm going to show you. So at the beginning of class, I started with some of those common, that algebra mistake that I said we sometimes see. And where that comes in is right here. If we get a negative 19 equals positive 19, that's not 0, right? Because in order for me to move this to the other side, what function do I have to do to get a positive 19 over here?
Subtract.
I have to subtract. And what's negative 19 minus negative, what's negative 19 minus 19? Not 0, right? It's 38. Negative 38. Okay, so just keep in mind that this is going to be negative 38, which is equal to negative 9.8 times. Then we can solve t, and we get a t that should give us 3.87, 3.87, 3.877, so 3.877. So that gives us total time in the air. But if you wanted to, you could solve it for just time. Now that's a delta y is equal to 0 problem. There are some times, like if I took a ball and I release it from here and it lands there, I were to talk from my hand to the floor, is that delta y is equal to 0? No, right? So there's a couple different ways you could approach like how long was in the air. You could say, well, this is 0, this is negative 1 meter, and you could solve for time. I think you'll end up having to do quadratic, just for the record. Most of the time people approach it where, and I kind of, one of the problems I kind of guided this way. I say, well, what about from here to here? If we figure out the time from here to max height, okay, and then I can say, well, what if I then go from max height and I move my hand and let it go back down? And if I find those two times, then I can add them together. And that's how we can kind of approach them. So max heights or delta y is equal to 0 problems are the kind of the last type of problems that we're going to do for this. So we're winding this unit down. I'll have to look to see when we're going to test on it. It might be towards the end of next week. I'll just say that. It might be towards the end of next week. I'll try to figure that out a little bit more specifically. So today I'll give you some time there to work on the worksheet called goes up, then goes down. So it's kind of that up and down max height problems. We'll probably continue on to that tomorrow. I have a due date set for Sunday evening. My guess is between today and tomorrow. Tomorrow's a short day. We'll get most of that done. And then, yeah, we're kind of winding down. So I got a couple of review things that I'll share with you. If you weren't here yesterday, we can get you that reaction time lab we can get that set up and going pretty quick. So we can get you that data. It's a pretty quick thing. So let me know what questions you have. The worksheets are here.